Good morning, students. Ngasigi oinadi mamangda home assignment pigi question number 1 to tawsiko. Question number 1 is find the inverse of this matrix by using elementary row transformation. Row transformation sizinaraga koina sida piribo matrix A se asigi inverse puthokoko. Duna first matrix A rese. Let A represents the given matrix, then write A is equal to I multiplied by A. Write all the elements of matrix A and the right identity matrix of order 3. Koina sida row de apply tawgadab se 1 tahangadab first element se ko aduga sigi mathang da ani se 0 lakhangadab ne diagonal element se 1 tahalo magi corresponding element ani se muk 0 salhan ba ko last the diagonal element A33 se 1 tahan ba remaining two elements se mukai tahan ba 0 sumain sigi step se somda leriba matrix ma'am se kanaga manahan gani identity ga manahan gadam ne ko duna si 1 tahan ge hai taradi study -1 lere ko duna applying kana apply tawre first row double arrow second row first row ga second row ga interchange tawro interchanging first row and second row we have 1 2 3 -1 1 2 3 so interchange tawre se 0 1 0 and 1 0 0 nangi third suba row se change samta leite ko matrix A ire next sida 1 legre ko dudi my corresponding elements amana -1 ni amana 3 ni ani se 0 ta hanaba same seba since 1 plus -1 is equal to 0 so the operator will be second row plus first row kaida pangthokani second row de ko third suba row sigi oina de koina scalar am changi all the elements of first row should be multiplied by -3 and adding to the corresponding elements of third row we get element A31 will be equal to 0 si ani max 0 tahanaba koina operator e duni ko second row gi damakta di kana plus tawrani second row ga first row ga plus tawrani aduna second row da ani se plus tawtho 1 plus -1 0 2 plus 1 is equal to 3 3 plus 2 is equal to 5 then for right hand side kisu 0 plus 1 1 1 plus 0 is equal to 1 and 0 plus 0 is equal to 0 third sub row se r3 da di koina first row sida hana kaina multiply tawgani -3 na multiply tawgani ko sida -3 na first all the elements of the first row multiply by the scalar -3 and added to the corresponding elements of third row we get the elements of all the elements of third row subasigi elements si operator se apply to rafang duni ko 1 into -3 plus 3 is equal to 0 2 into -3 -6 tare ko si 1 si da hapadi -5 3 into -3 -9 -9 se 1 si da hapadi kya ga manare -8 sigi same case se somda se apply tawrasi ko 0 into -3 is 0 0 plus 0 is 0 1 multiplied by -3 -3 plus 0 is -3 0 into -3 is equal to 0 and 0 plus 1 is equal to 1 sigi step sida si ahanbada 1 tahangadaba ko ani se 0 sale chume ko mathangda sigi diagonal element a22 se 1 tanaba same seba nanga first row sida 1 legi tardi first row se interchange tawbe address sizinaba su address ko fix tawre housing nang na sizinaduri se second sub row se ga third sub row se ka ngai anista nang 1 taba ngambra yengasi 1 haiba sidi yaudre ko 1 se kamain tahan ba ngammi herdi 3 da 2 na multiply to the 6 tai 6 se ina -5 ta hapadi 1 taba ngammi ko and -5 se kanada lay third sub row se lere adudi r3 tends to r3 plus 2 times of second row mana main ter se kaino second row gi element nam se da 2 na multiply to ro aduga kanada hapani third sub row se da kai gi maram gi tawrino herdi 1 haiba se 1 tarak na all the elements of second row multiplied by 2 and added to the corresponding elements of third row we get si mapa 0 sale 3 into 2 6 tariko 6 plus -5 plus 1 and the 5 into 2 10 10 plus -8 is equal to plus 2 samana na som the apply to say 2 into 1 is equal to 2 0 is plus 2 2 into 1 plus 2 plus -3 it will be equal to -1 2 into 0 is 0 and 0 plus 1 is equal to 1 siga chamana na fange next subjects the 1 tabadagi de koina ani se interchange tawthongnaraga diagonal element a22 have a 1 tabanga meko interchanging second row and the third row second row ga third row ga se on thongnar second row becomes third row and the third row becomes second row then right to left to samana and apply to see object 1 tabadagi di magi corresponding element 2 siga sigi 3 siga sa 0 taraknaba semoba 0 taraknaba seme first row dadi 2 lebanina scalar se -2 sida 1 legrade in hojik sijina duise second row iduni ko second row sijinare sina first row se 0 salan gaitar di second row da -2 na multiply torani aduga first row da happen aduga third suba row sigi oina di 3 se leba 3 sigi 0 salan gaitar di 1 should be multiplied by the scalar -3 -3 se hapkani maram di kaigina 3 plus -3 have a value se kya gamana bagi 0 ko first row apply torasi all the elements of the second row multiply by kaina multiply torani all the elements of the second row multiply by hanbagi se -2 ni ko -2 na multiply tor -2 into 0 si 0 chale ko si dum 1 tare 0 plus 1 1 tagre 1 into -2 plus 2 is equal to 0 2 into -2 is -4 -4 plus 3 is equal to -1 and apply this operator on right hand side to apply to siko -2 2 into -2 -4 plus 0 is equal to -4 -1 into -2 minus plus 2 dareko 2 the 1 hapadi 3 and 1 into -2 plus 0 is equal to -2 then for third row apply this operator all the elements of the second row multiply by -3 na multiply to 0 into -3 plus 0 is 0 1 into -3 plus 3 it will be equal to 0 and 2 into -3 -6 plus 5 is equal to -1 siga chapmanana som the store siko right hand side tasu 2 into -3 -6 plus 1 is equal to -5 -1 into -3 plus 3 3 is 1 the hapadi 4 tareko 1 into -3 plus 0 is equal to 0 so main taraga nangi first step se si 1 tahanba 0 salanba ko simo 1 tahanba ani simuk 0 salanba mathangda diagonal element a33 se kai tanaba semakani 1 tanaba semo diagonal element a33 se a 1 tanaba sengi ko see 1 tahan gay tardi -1 into -1 se +1 and all the elements of the third row should be multiplied by the scalar -1 we have the diagonal element a33 is equal to 0 sigi third super row se -1 alone multiply to 0 0 plus minus plus and 4 multiplied by -1 -4 minus is ends into +3 see 1 dagre ko magi corresponding element se amana 2 ne amana -1 ne ani simuk 0 tanaba same seva sigi -1 se kai de lay first row de lay sigi 2 se kai de lay second row still lay riba 1 hai se 1 se kai de lies tawe third suba column de row de lay ko aduna r3 na denoter ani nangi first suba row sigi di 1 ga -1 ga plus tawa se 0 taba fange adoga second suba row sigi di nangi third suba row sida hana kaina multiply togani -2 na aduga kanada hapkani added to the corresponding elements of second row then we get the element a23 will be equal to 0 sing by this element nam say identity tarak na sembani identity tabagi step to nangna follow togdegras anka hot pase warakani ko adugini applying r1 tends to r1 plus r3 see apply to rasi sis tab se le 0 plus 0 1 plus -1 0 tareko solve the sum and whole 5 plus -4 1 -4 plus 3 is equal to -1 plus 3 plus -2 which is equal to +1 second row gi samay apply tawra second row da nangi third suba row sida hana kaina multiply tawgadaba -2 na 0 into -2 0 1 masagi element se loin tajare ko 1 into -2 se 2 da hapadi kya tare 0 som the identity tagre ko apply this operator on right hand side also first multiply elements of third row by -2 5 into -2 -10 -10 plus 2 equals to -8 -4 into -2 plus 8 plus 8 plus -1 is equal to 7 3 into -2 is equal to -6 -6 plus 1 is equal to -5 for any matrix A there exists this matrix and A multiplied by this matrix is equal to identity matrix A is sigi matrix na multiply to use identity tareko therefore A inverse will be equal to this matrix kona A inverse ki matrix sigi se tare and hierarchy nangna ahanbada hottuise 1 tahanba si 0 chalanba ko 1 tahanaba semba anisimu 0 tahanba 1 tahanaba semba anisimu kai tahanba 0 sigi rule se apply tawrasi ko stanangi matrix lore. Next topic chapter number 4 determinant. It carries 6 marks. Determinant sida mark ya lerani 6 marks laiduni ko. So let's define determinant. Let A be a square matrix whose elements are A, B, C, D. Then the unique number, kamaina pira A, unique number which is given by the product of diagonal elements. Diagonal elements is A and the D minus the product of remaining two elements. Atop lemhoriba number ani se product loredana ani se gi difference se real number am phangni ba associated with the matrix A is called the determinant of A and it is denoted by A enclosed within modulus symbol. Modulus symbol ga manaba ani modulus ka property manade ko. Nangonde any square matrix sum pire square matrix segi product of diagonal element minus the product of remaining two elements kai kawe determinant of the matrix aina kawe ba. The determinant se kai de exist away determinant exists only in square matrix. Square matrix khatang da nangi determinant se exist only ko. Example A. So that matrix A ma pire magi elements sing se 2 3 minus 1 and 4 haina pire ko segi determinant putho o haita dc symbol se irani A enclosed within second bracket segi symbol se ito e ko segi iraba matungda nangna hoturi se kaino hanbada diagonal elements putho. What are the diagonal elements? Diagonal elements are 2 and 4. 4 into 2 sithame ko formula gi minus sum laijani. Remaining two elements the 3 ga kai ga tare 3 into minus 1. 4 into 2 is 8 and the 3 into minus 1 minus 1 minus minus plus 8 plus 3 is equal to 11. 11 is the determinant of the square matrix A. Now when the period matrix A sigi determinant hangadi kai ga manare 11 tare ko and so determinant of any square matrix is a real number. It may be 0 positive or negative. Now positive tabe negative tabe 0 tabasu yai ko aduga number do kai oini haba real number amo oini ba determinants yare. Next determinant gi tongan bani makal ni ko determinant of a matrix of order 1 nangi matrix in order 1 already magi determinant se kamai puthokani ko determinant of a matrix of order 1. Let A be a square matrix of order 1 whose elements is A. Be a matrix of order 1, then the determinant of A is defined as determinant of A. This element A should be enclosed within modulus sign and is equal to A. Modulus की property का determinant का मानते को determinant of 3 it will be equal to 3 and determinant of minus 3 it will be equal to minus 3. Plus layer masu plus thora ani minus layer masu kayo na thora ani minus oin thora ani ko aduna modulus की symbol का manaraga su modulus की property na teva. Next determinant of matrix of order 2. Nangi matrix in order 2 oiragadi hojik tawgibadu ga chap manare ko let A be a square matrix of order 2 whose elements are. Then the determinant of A is defined as determinant of A. Determinant haradi all the elements should be enclosed within this modular sign is equal to product of diagonal elements. Here diagonal elements are A11 A22 minus the product of remaining two elements. This is a real number. This real number is called the determinant of the square matrix A. Next, determinant of a matrix of order 3. Handak na nangi order se kya pirani 3 ko. Let A be a square matrix of order 3 whose elements are simamang the takre ko A11, A12, A13, A21, A22, A23, A31, A32, A33. Be a square matrix of order 3. Then the determinant of A is defined as. China kamay define tawgani determinant sida nangi order se ahum laigani nangi number of rows se ahum lairani number of columns isu kya warani ahum ko aduna nangi any one of the rows or any one of the columns te expand tawu yaiba nangi determinant se ina first row de expand tawri na khalagadi first write A11 A11 se an iduni ko then write the determinant obtained by deleting first row and first column in which this element A11 lies. A11 lies the rows ka column ka se ka o this element am se lam hodra si irakadava ko A22 A23 A32 A33 then write minus A12 second element si irasi ko then write the determinant obtained by deleting first row and second column. First row ka second column ka se ka kana kana lemhawe a21 a23 a31 a33 si thame ko plus then write the last element is a13. In this case, write the determinant obtained by deleting first row and third column. Handagna first row ga third column ga ko. Remaining elements A21, A22, A31 and A32 sitare ko. Then determinant of order to expand to bude hausi haigre ko. Product of diagonal element minus the product of remaining two elements. A11 into product of diagonal element minus product of remaining two element minus A12. Anisigi product an hosiko A21, A33 minus A23, A31 plus. Last element is A13. The product of diagonal elements palo A21, A32 minus A22 and A31. Sigi mayam se koina value puthoka na real number am phangneba. The real number is called determinant of a square matrix of order 3. Aduna sigise aina first row de expand tobagi rule ni, second de expand torsway, third de expand tobusway, first column dorsway, second column dorsway, third column dorsway ko. Aduna determinant na expand tobukanda koina sign khara follow tawni adugi sign sing se take ko. Signs to be followed in expansion of any determinants are plus minus plus. Sina first row de expand tobagi, second row de expand already minus plus minus ka, and third row gi plus minus plus. If the determinant is expanded in column 1, then signs will be plus minus plus. For second column it will be minus plus minus, and for third column it will be plus minus and plus minus. Si sign se koina follow tawra ini ko. Example lama yengase ko. Find the determinant of this square matrix A of order 3 whose elements are given like this. My period ng element naam se ko determinant puto o hai kamai kai de expand taw se ga kai de live se r1 de expand taw ren khale ko. R1 means first row ne. Expanding the determinant along first row 2 ire 2 se ire ko nang si kak thalo. Find the determinant obtained by deleting first row and first column. Remaining elements 5, 6, 1, 3. See determinant oigadava ko. In a first row the expander or the sign se plus ne, minus ne, plus ne dadin. See the plus ire ko. Second sign will be minus. Then write the second element. Nangi first row the layer elements in se 2 ne, minus 1 ne, 3 ne. First elements in a 2 dare. Second elements se minus 1 ne. Hanagi form lagi minus sign ang galay ko. Then find the determinant obtained by deleting first row and second column in which this element minus 1 lies. Sige minus 1 lies the riba rows ka column ga se ka o dudi kana fange 0, 6 and 2, 3. Si phangore ko. And third element will be sign will be plus and the third element is 3. Determinant iro find the determinant obtained by deleting first row and third column. First row ga third column ka 0, 5, 2, 1 tare ko. 2 ira into then expand this third determinant. 5 into 3 15 minus 6 into 1 is equal to 6 minus minus plus tare ko 0 into 3 0 into 3 0 minus 6 into 2 is equal to 12. See minus cd nangi determinant expand over the thoksar formula ni plus 3 ko 0 into 1 is equal to 0 minus 2 into 5 is equal to 10. 15 minus 6 9 tare minus 12 plus 1 minus 12 minus 10 into 3 is equal to minus 30. 2 into 9 18 minus 12 and minus 30 si maam se ani se plus tok se number se minus 42 dare ko. Difference puto difference of 18 ga 42 ga di kya ga manare minus 24 is the determinant of a matrix A. Then let's come to exercise 4.1. Exercise 4.1 yung si ko. Evaluate the determinants. Determinants है question number 1 से अंग question number 1 की determinant number. Determinants are represented by this small triangle. Small triangle is delta kawiko. Delta na represent all. Let delta represent this determinant. Elements are 2, 4, minus 5 and minus 1. Stanangi diagonal element kalo. Diagonal elements are 2 and minus 1. Find the product of diagonal elements 2 into minus 1 minus product of remaining two elements 4 into minus 5 minus 2 minus minus plus minus 2 plus 20 is equal to 18. 18 is the determinant of this square matrix. Nangi pyramid determinant की value से क्या गमाना रहे 18 का. Next question number 3. if A is a square matrix, then show that determinant of 2 times of A is equal to 4 into determinant of A. Nangi matrix A da 2 na multiply tawagi determinant lawbaduga 4 into determinant of A ga mane ne so tawdeni ko. Question number 3. There is a square matrix of order 2 whose elements are given. Then we have to show that this expression left hand side is equal to right hand side. Left hand side the 2 times of A haiba myawi ko. Sigi value 1 hot say 2 times of A means all the elements of matrix A should be multiplied by 2. 2 into 2 4, 2 into 4 8, 2 2 4. Then find this determinant. Determinant will be 2 4 8 4. Product of diagonal element whole 4 into 2 8 minus 8 into 4 is equal to minus 32, and their difference is equal to minus 24. Chinanangi left hand side ki value pange ko for right hand side 4 into determinant A 4 determinant of A 4 ire ko matrix A se determinant ki form de ito 1 2 and 4 2 4 into 1 into 2 minus 4 into 2 is equal to 8. Determinant ki rule pale product of diagonal element minus the product of remaining two elements. 4 into we get minus 6 minus 24. So left hand side is equal to nangi value se kya gamana rani. Left hand side is equal to right hand side. Next question, question number 5. Evaluate the determinants. Determinant mari pire ko Roman number 1, 2, 3, and 4. Kun Roman number 2 da katang torse. Koina determinant da khang se ko we can expand any determinant, any rows or any columns to expand the way. Nangi determinant amase any one of the rows or any one of the columns to expand the way. And the key oina di a second row to expand the way ko. So that let delta represents the given determinant. Expanding the delta along second row we get nangi determinant se second row da koina expand the sign se kram follow the rani minus plus minus rani ko. Then check the elements of second row. Elements of second row are 1 1 and kai kamana ni minus 2 have a kamana 1 1 minus 2 have in the first right. Sigi form lagi minus 1 ire ko. Determinant iro. Find the determinant obtained by deleting second row and first column. Second row ga first column ga ko. The minus 4 5 3 1 leme ko. Sign gi plus. Second element is plus 1. Then find the determinant obtained by deleting second row and second column. Sigi 1 sinalize to busimu kakthale. Kana phangawre 3 5 2 1. 3 5 2 1 se phange ko. Minus thame sign gi matungin. And the third element of second row is equal to minus 2. Sigi minus 2 na lies the rows the column ga sikak thalo. Kana lem haure 3 minus 4 2 3. Determinant gi form the ireko. Then expand this determinants. Minus 1 minus 4 into 1 is minus 4. 5 into 3 is equal to minus 15 plus 1. 3 into 1 is 3. 5 into 2 is equal to minus 10 plus minus minus plus 3 3 9 minus 4 into 2 minus 8 minus minus plus tareko magi form lagi minus am galaini minus 4 into minus 9 15 minus 19 minus minus plus 3 minus 10 is equal to minus 7 9 plus 8 17 17 into 2 ireko 19 minus 7 kya lem hore 12 lem hore and 2 into 17 34 plus down already 46 46 is the value of this determinant. Sigi determinant ki value sa kya gamana re 46 tare ko. And let's come to question number 7. Find the value of x if haraga sigi determinant ani manare ko. Left hand side ta piri sigi right hand side ki determinant siga manare. Then we have to find the value of x. This determinant is equal to this determinant. 2 into 1 2 minus 4 into 5 10. Expand to 2x into x 2 times of x square minus 6 into 4 24 minus 18 equals to 2x square minus 24. See transpose to transpose minus 24 from left hand side to right hand side to left hand side. It should be plus the same story. 2x square is equal to minus 18 plus 24. And it's a plus down already. Difference put all this 6 pang x square 2 na divide to 3 fange. So x will be equal to plus minus root over 3. Nangi possible values of x plus minus root over 3 tare. Then for question number 8, if x is x to 18x determinant, this determinant is equal to this determinant, then the value of x is equal to nang option kya pire, option se mari pire ko, option A, option B, option C and option D. Sidagi nang na achumbam khalase. The x to 18x type of matrix sum pire sian expander. Si expander bukan x into x square minus 18 into 2 is equal to 36 equal to nangi determinant expansion se diagonal products in handu ni ko 6 into 6 36 minus 18 into 2 is equal to 36. 36 minus 36 is equal to 0. X square transpose this constant from left hand side to right hand side, it should be 36 plus wale ko. Taking square root on both sides, x is equal to plus minus root over 36. Since the square root of 36 is equal to plus 6, so the possible values of x are plus minus 6. Aduna nangi correct option se option kya diya? Option number B diya ko. For today, let's end here.